of the sides and angles. Now let us see the first shape that is represented on this board, that is the four sides of a quadrilateral are equal, that is AC, CD and DB and AB are equal. Therefore, the four sides, when the picture or when the figure having the four sides equal and the four angles is equal to 90 degrees, that is, then the figure is known as the square, or the quadrilateral is known as the square. When it is stated that when four sides and the four angles are equal for a quadrilateral, then it is known as square. And for a rhombus, a quadrilateral is said to be a rhombus when the four sides are equal but the angles are not equal to 90 degrees. Now let us discuss the properties of a quadrilateral in order to form it as a rhombus. That is, the four sides will be equal for a rhombus, that is AD equals to BD and BD equals to CB and CB equals to AC. And the angles within the rhombus is not equal to 90 degrees. And let us see one more picture, that is figure, that is ABCD as shown, but the opposite sides are only equal, that is AB is parallel to CD and AC is parallel to BD. That means the opposite pairs will be parallel to each other, but the angles will be equals to 90 degrees, that is perpendicular to each other. Therefore, the laws or rules in order to be a rectangle for a quadrilateral is the opposite sides should be parallel to each other and the angles should be equals to 90 degrees. And let us see one more picture, that is quadrilateral figure or four-sided closed figure. That is, it having four sides but the sides are not equal to anyone, or the sides are with different sizes and the angles are of different angles and they are not oppositely parallel, then the figure is said to be the basic figure known as quadrilateral, right? No other name is given for that figures. And let us see another figure, that is, if the sides are parallel, the opposite sides are parallel to each other, that is AB is parallel to CD and AC is parallel to BD and the angles is not equal to 90 degrees, then it follows the rule of parallelogram, right? The quadrilateral is said to be a parallelogram. Now let us, I have previously said about the trapezium, that is the only one pair of opposite sides will be equal and the angles will not be equal to 90 degrees. And let us take one more different figure, that is as shown here, the two adjacent sides. That means AD is equals to CD and AB equals to CB, that is only the adjacent pair of sides will be equal. Then that shape or that figure is known as the kite. Means see, you can see generally that is in a kite shape, right? So the name given is kite for that quadrilateral shape. Now we have seen these different figures which are coming or following under the quadrilaterals, but let us see the rules, what is what and what. That is, a square can be said to be a rhombus or a rectangle, but a rectangle cannot be called as square and a rhombus cannot be called as a square because it doesn't have all the angles equals to 90 degrees. And here the rectangle fails to form a square because all the four sides are not equal. And a parallelogram is called as trapezium and a parallelogram is called as a kite, but a trapezium cannot be called as parallelogram and at the same time a kite cannot be called as parallelogram because they are failing the rules of two pairs of opposite sides to be equal. By this we can state down square can be called as rhombus, rectangle and also so on. And let us see the properties of parallelogram. That is, the first important property of a parallelogram is a parallelogram consists of two congruent triangles. That is, let us take one parallelogram that as shown in figure, that is A, B, C, D are the vertices and AC is the diagonal which is dividing the quadrilateral into two equal parts. That is, the first triangle and second triangle, that is ADC and ABC. And let us assume or let us suppose that this triangle ABC has been reversed. Then it will be exactly fitted in the place of the triangle ADC, right? That means this itself can say that the congruence nature of these two triangles. Therefore, the first basic property of a parallelogram is it is consisting of two congruent triangles, right? And the second property of a parallelogram is the two opposite sides are equal as shown previously. That is DC equals to AB. That means these two are in parallel to each other. That is they are in parallel. And AD is parallel to BC. Opposite sides of pairs will be in parallel. And the third property is the opposite angles of a parallelogram are equal. That means angle A is equals to angle C and angle D equals to angle B. This can be proved by using the following theorem. Let us see it later. And the fourth property of a parallelogram is the diagonals bisect each other. I have previously said a parallelogram has two diagonals, that is AC and DB. These two diagonals bisects each other at point O, let us assume. And let us see the proofs related to these properties of a parallelogram. We have discussed the four properties of a quadrilateral. That is, a quadrilateral becomes a parallelogram, or it's said to be called parallelogram when these four properties are followed or verified. That is, it should be followed by the quadrilateral. That means the two opposite sides should be parallel to each other and the diagonals should bisect each other. That is, let us see the meaning of bisect. That is, when two lines, that is when AC and DB are intersecting at a point O, right? And bisecting means it is dividing the two parts, that is the angle between those intersecting lines is 90 degrees, and at the same time the distance or the length between the two parts will be equal. I mean to say that OD will be equals to OB and OA equals to OC. It is dividing exactly into two equal parts. Bisecting nature is, that is, and the angle will be equals to 90 degrees. Let us see how the angle is 90 degrees. Now let us take the triangle ADB and the line DB will be a straight line which is having half of the angle of a circle, that is equals to 180 degrees. Now let us say that angle AOD, that is angle AOD plus angle AOB equals to 180 degrees. As we have learned this property in triangles, and therefore we can say that I have previously said that two triangles of congruency will be equals to a quadrilateral, right? That is the first basic property of a quadrilateral. Now let us assume that AOB triangle is exactly in coordinates with AOD triangle, and therefore we can write that AOD will be equals to triangle AOB, and therefore it can be said that 2 times of angle AOD equals to 180 degrees, and therefore angle AOD is represented as 90 degrees. Hence we can state or we can verify that the angle that is bisected by the two diagonals, that each part is 90 degrees, therefore 4 parts, that is sum of 4 into 90 degrees, it will be equals to 360 degrees. And the opposite angles of a parallelogram is equal, that is angle A equals to angle C and angle B equals to angle D. And let us see the one more major property of parallelogram, that is midpoint